Welcome to the Feliscope. My name is Zach Bradford.
My name's Tyler Thomas.
And this is our senior project. For this project, we wanted to make a dynamic laser toy and water discipline system. It had many systems a part of it, and which included object recognition, a water spraying system, a laser targeting system,
A pan tilt system.
To target with the laser, and it was supposed to be all backed up with a battery. We want to go ahead and show you a demo of what it was intended to be. We accomplished quite a bit of it, but let's just go ahead and show you what we originally thought it was supposed to be. So, as we can see right here on this slideshow, we have two objects. We have this laser device right here that's intended to be the Feliscope. It's a very small condensed version and a table. Okay, so we designed this around cats. So let's generate a cat. Here we go. Here's a little bust of a cat. Ideally, what we wanted it to do is if a cat walked into a room or in frame of the Feliscope, it would generate a play area that the user defines. So here's a picture of, a rough idea of what a play area would be. The cat would be drawn to it because it's a laser, and it would play in the user-defined area like this. He would run around in the corners. That's what it was intended to be. However, we wanted to add extra features to where if the cat jumped on an undesired surface like a table or a bed or anything, fill in the blank, it would deter the cat from doing such. So, for example, we have a table. The cat jumps on the table, right? Well, the device, the Feliscope, was supposed to turn off the play area and then initialize a water sprayer as well and spray the cat, not lethally, it's water, to make him want to come down and be in the desired area.
So only when the cat is on the table or above a certain height is when the water will spray the cat, and when the cat gets down, the play area can come back.
All right, so let's get a little bit more in depth as to what the features were explained more than just pictures. Okay, first, there's an object recognition system. It's geared for felines. And we wanted to implement stereo vision for depth, so that requires...
The stereo vision for depth requires two cameras. The cameras have to be calibrated, and a disparity map has to be produced in order to get your Z value. If you have X, which is left or right, you have Y, which is up and down. Z is simply how far away or how close you are to the camera.
The pan tilt system, this is supposed to be the ability for it to move a laser and a water shooter X and Y.
I was going to say one stepper for the pan, another stepper for the tilt in order to aim the laser and water nozzle accurately.
This is, we wanted to make it where it's 3D printed. We didn't want to use any aftermarket parts. The other system is a laser targeting system. The pan tilt system with the stepper motor is supposed to be, aligning the laser to where its destination should go. And we wanted to do a red laser. And we intended to have a user be able to set the play area themselves with a GUI, a graphical user interface.
And once the user sets that play area, the laser will only go within the bounds of that play area. And while it's within the bounds of that play area, it would be using the object detection to track the cat in order to dynamically move the laser as the cat's being tracked.
The next system was the water spraying system. This one played into the Z value as well. We wanted to be able to put adjustable pressure on the nozzle. So, for example, if the cat is far away, you need to apply more pressure so the nozzle can spray water further. The fifth system is we wanted to make it where it was self-contained, all on a battery, no AC. We wanted it all to be DC. That included the peripherals and the Raspberry Pi itself, which is the operating system and the platform in which we designed this.
And then again.
object recognition system, we implemented it, kind of. We did make it geared for felines. However, we didn't actually get to implement the stereo vision as we intended to.
So, excuse me. So we use YOLO V4 Tiny in order to detect a cat. And of course, we were detecting this bust here. And we did it pretty well with YOLO V4. YOLO V4 did well, but as far as the stereo vision producing the disparity map came out a bit too noisy in order to use the Z value.
Second was a pan tilt system. We pretty much aced this. We did 3D print it completely, and we did get it stepper motor driven. It works pretty fine. 3, laser targeting system. We got this pretty much done. We had a red laser as we intended. Should have probably used a green laser. Found out in post that the human eye and webcams and whatnot, they're designed really to detect green better. We did not implement a GUI with a user set play area. We just didn't have the time to do it. However, as you saw in the demo, we did make it to where it could target the cat pretty decently. The water spraying system, it works. And I'll show some B-roll here. However, it leaks quite a bit. It's not the best. And since we didn't have the best accuracy with the laser, figured it was a little bit too risky to implement it here. The biggest system that we really wanted to implement was the depth a pressure system. And since we never got the stereo vision worked out, we were unable to implement the depth or the pressure that we could adjust it for. Okay, system 5, battery powered and self-contained. This works. However, the Pi says the voltage is too low. I have enough headroom for amperage. I don't understand.
I enjoyed working on this project. There were times where things don't work out, and we just pivoted and figured it out, and we made this cat be tracked and aimed by a laser on a pan tilt system dynamically.
But thanks for the time, and this has been the Feliscope.
And thank you for watching the video, and we hope to produce more products that are better than this in the future.
Yep.